Hello guys, good evening all of you. Good evening.
Hello guys, good evening all of you.
All right. So let us start the class, sir. I hope people have joined. Very good. So welcome to today's class. We'll be starting engineering mathematics, sir. This could be a demo class. So we'll try to understand what is engineering mathematics, what is the weightage of it, and we'll take up a particular chapter and we'll start that chapter. We'll finish one topic, right? All right. So engineering mathematics is basically an easy subject, sir, which has a weightage of 12 to 15 marks. It has a weightage of how much, sir? 12 to 15 marks in GATE examination, right? It basically has 6 chapters. So from each chapter you could say approximately you could get 2 marks or sometimes 3 marks in one of the chapters. So you would get 12 to 15 marks, right? In this 12 to 15 marks, it is very easy to secure 10 marks. Very simple. If you follow the course properly, if you practice the notes and previous year questions properly, then it will be very easy to secure this 10 marks from 12 to 15. The other 2 marks or the 15 or the 5 marks are basically somewhat tricky questions can come, or in fact you can actually, if you work hard a little bit, you can easily get 12 marks also, right? But every student should get a easy target of 10 marks. Very good. So this chapter we have, like this subject we have, we'll talk about algebra, that is matrices chapter, sir. That will be the first chapter. Then we'll talk about calculus. Then you'll have differential equations. Then you'll basically have complex variables. You'll also have probability and statistics. You'll have numerical methods. And transform theory. So based on your department, maybe all of these chapters will be there, or for some branches there will not be some of the topics, right? If you are a computer science students, then maybe all of this is not there in your syllabus. If you are an electrical, electronics or a mechanical student, maybe all of this is there. But this would be the entire syllabus of your engineering mathematics, right? So in today's class, what I'll be doing is I'll take up this particular chapter called as calculus, which is most important, sir. In fact, this is the lengthiest chapter. This is the lengthiest chapter of all of this. So and of course I know that this particular chapter is there for all the branches. So let me start this particular chapter, right? If you have any doubt regarding anything I'm talking about, you can always write it in the chat. I'll read your message and obviously I'll reply to it, right? Very good. So let us start our discussion on calculus. So let us first understand what is the meaning of calculus. What is the literal meaning, sir? What is the literal meaning? Anyone, if they know, they can actually write it in the chat. What is the literal meaning of the word calculus? Anyone, sir, who can tell me what is the literal meaning of the word calculus? What is the word meaning, calculus meaning? Because from there only we will derive what all topics are there, how they are there, why you have to study, and why it plays a very important role in all engineering subjects, right? So can anyone tell me what is the literal meaning of the word calculus? Yes, sir, I'm waiting for the reply in the chat. This is the most important chapter, sir. Calculus has more weightage, lengthy and important. Because if you don't know calculus, then you're going to suffer in other technical subjects of engineering also, because this is very much needed for all your engineering background, right? So that's why this is the second chapter of your engineering mathematics. So let me tell you the literal meaning of the word calculus. It is actually a Latin word. It's basically what, sir? It simply means pebble, or you can say a small stone. In which language this is there, sir? This is derived from the Latin language. The meaning of this is small pebble or small stone or pebble, right? Try to understand why this is important or significance of this. Basically, if you just go back in the history, people used something called as abacus. You might have seen this kind of instrument somewhere in your basic computer science or basic, whenever computer is introduced in the say 5th class, 6th class, you might have seen something called as abacus. What is abacus, sir? Abacus is, it's an instrument. It's an instrument used for counting. Used for counting. So how does abacus look like? It would actually look something like this. You might have seen this somewhere. It will have actually 5 of this, and it will have beads like this. It will have beads like this. So one of the small bead, so all of the rails will have bead. So this small bead, this small stone is called a pebble. This is a small stone. From this particular small stone only, the chapter name has been derived, calculus, right? So what is the literal meaning of the word calculus? The literal meaning of the word calculus is nothing but a small stone, right? So you have to understand the importance of this word small, right? Now I'll tell you why this small is important. Basically, this particular calculus chapter is divided into 3 main parts. One is differential calculus, then you will have integral calculus, then you will have vector calculus. Now maybe this vector calculus is not there for everybody, but obviously electronics, electrical, mechanical, civil people have vector calculus also in the chapter, right? So now, as I told you, what is the meaning of calculus? Calculus is nothing but a small stone or a pebble, right? So basically, what do we do in differential calculus is, we will study about small change. We will study about what? Small changes or differential change. That means you will study about something called as dx, something called as dy, or the ratios dy by dx. So this is what you will be studying about in your differential calculus, right? In fact, what is the meaning of the word differentiation? Differentiation simply means slope. Differentiation means what, sir? Differentiation means slope. What is the meaning of slope? Change. How do you write slope at a point? Say you have a function y is equal to f of x, then what is the meaning of dy by dx at say x0 comma y0? This will tell the slope of the function f of x at x0 y0, right? So we'll be studying about small changes, dx dy. We'll look at the ratio. That means if the x changes with a small length, say if x changes with a small quantity of dx, then how is the y changing? That is the relationship between dy by dx, which is nothing but slope. Slope tells us what? How is y changing when x is changing by small quantity, right? Similarly, in integral calculus, what do we study in integral calculus, sir? Integration, the meaning of integration is nothing but summation, accumulation. What is the meaning of integration? Integrating things is accumulating, right? When you actually write integral f of x dx or simply say integral y dx, what does this tell you? This tells about area under the curve. So basically how this chapter is divided is, this particular calculus is divided into small parts. The different parts are differential calculus, integral calculus and vector calculus. In differential calculus, we'll be mainly talking about slopes or how a function is changing whenever its variable is changing. That is, whenever dx is changing, how dy is changing is what measured in your differential calculus, right? So based on this only you have applications like what will be the length of the curve? What will be the length of the curve? There are other applications also, like what will be maxima point, what will be minima. These are all applications, sir, which are actually very important, right? Similarly, when you have integral, we have area, we have surface area, we have volume. All those things can be found out from the what? Your integral calculus. So integration means accumulation. If you observe here also we are dealing with what? Small change in x dx. That is why integral calculus, right? Very good, sir. Now, what do we deal in vector calculus? What do we deal in vector calculus? In vector calculus, we actually study about small change in length, small changes in length. So we will study dl, dA, dV, right? If you are an electronics student, then there will be a subject called EMFT, where differential length, differential area, differential volume is very important whenever we are applying some important theorem. So one common thing in all of these things which I am telling is the word calculus. What does the word calculus mean? Calculus simply means the small pebble. That means we are studying something about small thing. So what is that small thing, sir? In the differential calculus, we'll see dy by dx. So how is the small change in y whenever there is small change in x, right? That defines the slope of that particular y, which is y is equal to f of x. That is small change we are seeing. That's why differential calculus. Similarly, what we are seeing in integral calculus, small areas we are finding. What is f of x into dx, sir? Small area. What does integration means? When you accumulate all those small areas, what are you going to get? The entire area under the curve you are going to get. Now, what does vector calculus deal with? What is vector, sir? Vector is something which has direction and as well as magnitude, right? So in a particular direction, what is the differential change in length? In a particular direction, what is the differential change in area? What is the differential change in volume? All these things we will study. We will obviously study something more called as, we have divergence, we have curl, and all those things are there. But for them to understand, we'll have to understand these things. Then we have to understand the basics of vector, right? So I hope you got a basic picture or an idea of what is the calculus, why we are doing this. Because in engineering subjects, whenever you want to derive something, definitely you will use differentiation, definitely you will use integration. That's why this becomes the most basic chapter, right? If you are failing to understand how the differentiation works, why we are doing dy by dx equal to 0 whenever you want to find the maximum value of it or minimum value of it, or say if you want to find the area under something, how do you do it? If you don't understand these basic things or how to do these things, then you will obviously not understand what is going to happen in your technical subjects also. So this particular chapter is a very basic and a very must chapter for all the engineering branches, right? Engineering can be nicely understood with the help of mathematics, with the help of derivations. To do that, you need to be good at calculus. So there are two benefits in learning calculus. One, you will get 10 marks, like as I told you, we are engineering mathematics of 10 marks weightage. So you're definitely going to get 10 marks out of this, and it will definitely help you better understand your technical subjects, right? So if you have anything to ask, this is the time, sir. You can ask anything in the chat. I'm going to definitely answer that. So if at all you have any doubt so far, you please write it in the chat box. I'm looking at the chat. If anyone has any doubt, you write it. If you don't write anything, I'll assume that everything is good so far and I'll move forward. Right? Very good, sir. So I'll be waiting for any one of you to write any doubt. If you have any doubt, anything to ask, you can definitely write it in the chat box. Then I'm going to explain it. Then, or else, if you don't have any doubt, I'm going to move forward. Yeah. You could ask doubt, sir. Hey, sir, is all right. No doubt. All right. So let me move forward and let me tell you what we are going to start in this particular chapter. Now, to understand differential calculus, we have some things, sir. So let me tell you how this chapter is going to be. So I'll be starting your differential calculus. We'll be starting what, sir? We'll be starting differential calculus. As I told you, differential calculus deals about differentiation and their application. But before even going and understanding the differentiation, we have some more things to understand. It goes like this. First, we'll study about limit of a function. Then we will study about the continuity and the differentiability. Like this would be the basic which you might have studied. If you could remember in your 10th class, 12th standard, 11th standard, you might have definitely studied till here. Then you'll understand basic ways of integration, basic ways of evaluating differentiation. There are some standard ways in which you can evaluate derivatives. What is the meaning of derivative? I told, sir, derivative is nothing but simply slope. Then comes the most important part, the applications. Then comes the most important part, the applications. In any subject or in any chapter, this applications part is very, very important, because in engineering you are going to be tested on applications, sir. So make sure you understand the applications, or you put more focus on applications. This is basics. Then we'll apply this basics on certain topics which are called as applications, which are tested in your, say, any engineering exam, right? So the applications are like this. The first main application is maxima minima. Maxima minima. Then we have something called as Taylor and Maclaurin series. Taylor and Maclaurin series. Then we have something called as slope of a line or a function, right? So of this, let me tell you, sir, this is the most important topic. If at all, if I want to blindly put a question from differential equation, I'll be putting it on maxima minima. Then maybe I'll put a next question on Taylor series and Maclaurin series, which basically a lot of the students will have problem in this particular point, right? So this will be your differential calculus. Then a small continuation of this would be like this. You will study about, the fifth point will be, you will study about partial derivatives. Partial derivatives and their applications. So what do we study in your first 4 points is, again, this is actually elaborated again. Partial derivatives, will study limit, will study continuity, will study how to evaluate that. We have some theorem called as Euler's theorem, all that we'll study. Then again we'll study the maxima minima, the applications of partial derivative. The difference between the normal differentiation till here is, you have a variable y is equal to f of x. Then from here you will have a variable z is equal to say f of x comma y, or say z is equal to f of x1, x2, x3, or simply u, x, y, z. So whenever you have more than one variable, here what is the meaning of y is equal to f of x? There are only two variables. Of that, the two variables are what, sir? There's an x variable and a y variable, right? If you generally want to draw y is equal to f of x, how will you draw, sir? You will say this is your x and this you will say as y, which is f of x. So you have x and y. So x is basically what, sir? X is your dependent variable. Your x will be what? Your x will be an independent variable. And your y will be what? Y will be your dependent variable. So whenever you have only one independent variable, why is this independent variable, sir? Because this particular axis is an independent axis. Based on what point you choose on this axis, your value of y is going to come. So if I say your y is simply say this is say x plus 1, right? Some example I am taking, sir. If this is x plus 1, if your x is 0, then your y will be 1. If your x is 1, it will be 2. If your x is minus 1, it will be here. So it will be a line like this. So you can choose any value of x. Based on the value of x chosen, value of y is going to come. That is why your x is what? It is an independent variable. And what is your y? It is depending on x. That's why y is equal to function of x, f of x. That's why it is called as dependent variable. This is independent, this is dependent. Now whenever you come to z is equal to f of x comma y, how many independent variables are there? There is more than one independent variable. How many variables are there, sir? Here z is equal to f of x comma y, two independent variables are there, and z is the dependent variable. So how can this look like? This will look like this. This will be x, this will be y, and this will be z is equal to f of x comma y. So here we have both x and y. Based on the value of x and y chosen, your function z is equal to f of x comma y is going to result. So that's why z is your independent variable, sorry, z is your dependent variable and your x and y are independent variable, right? Now I cannot show 4-dimensional system. In reality we live in a 3-dimensional system world. So at max I can show 3-dimensional system only, but there can be some variables or some equations which can be on multiple variables also. So multiple dimension can be also existing, right? So very good, sir. So whenever we have more than one independent variable, we will be talking about partial derivatives. Whenever we have only one independent variable and one dependent variable, we'll be simply talking about differentiation. How does this look like? Here if I want to show, this will look like dy by dx. How will this look like? This will look like dou z by dou x or dou z by dou y. This is also called as del z by del x, del z by del y. So this is how the differential calculus chapter is going to be divided, and this is the basics of it, right? Now to go further, like to understand all these things, we have a basic concept to understand, which is called limit of a function, which is called as what? Limit of a function. If we understand the limit of a function, then we can understand what is continuity, what is differentiability. From there only we will find out how to evaluate. Then once you understand how to evaluate and what are the concepts behind it, you can easily understand the applications, right? So far if you have any doubt or anything to ask, this is the time to ask. Any small doubt you have, you can ask, sir. But don't spam in the chat. All right, if you have anything to ask, this is the time to ask, or else I will start the topic called as limit of a function. All right, I'll understand that there is no doubt so far. So let me move forward. So limit of a function is actually a very basic and an important topic which is forming the crux of your differentiation, because as you move forward you'll understand that to evaluate differentiation also, to evaluate derivative also, you have to evaluate limit. So you have to understand the concept of limit, right? Very good. So let us try to understand the limit of a function topic. So now the topic of discussion is limit of a function. What function we are talking about? We are talking about a single independent variable function. So I'll be dealing with something called as y is equal to f of x. Here you have to understand what this is basically your independent variable, this is basically your dependent variable, right? X is an independent variable, y is your dependent variable, right? Now before even understanding this part, let me just tell you some small concept which will help you easily understand this definition, right? So see sir, let us take a scenario like this. Say there is a scale like this. So this is the origin. So this is -1. So this is 1. So this is 2. Right? Now, see sir, there are two people here. Say this is person 1. Say this is person 2. Now, what is the gap, or if I ask you distance between the person 1 and person 2? This is, say, each of this is in centimeters or unit. This is 1 unit, you assume, sir. Between -1 and 0 it's 1 unit, 0 to 1 it is 1 unit, 1 to 2 it is 1 unit, right? So how many units of distance is there between person 1 and person 2? If I ask you this question, how will you tell, sir? You will say that simply, sir, there is 3 units of distance. There is 3 units of distance between person 1 and person 2, isn't it? You can answer in the chat, sir. How many units of distance is there between person 1 and person 2? It's 3 units of distance. Sir, how did I get this 3 units of distance? You could simply say like this. So this is 1 unit, 2 unit, 3 units. There is 3 units of distance. Or the other way is like this. Sir, 2 minus -1 is 3. Or you can write, sir, -1 minus 2 is equal to -3. But since we are talking about distance, let us put a modulus to it, make it positive and say 3, right? So whenever you want to find gap or distance between two particular points, say these two particular points, how can you find the distance or the gap between those two particular points? Just by subtracting those points, and you put a modulus, because whenever you subtract, it might so happen that the result might come as negative. To make it positive, I'll put what? I'll put modulus, right? Same way you can understand like this also, sir. So this is 0, this is -3, this is 5. What is the gap between these two fellows? What is the distance between these two fellows? How will you say? You will simply say, sir, 8 units. How? You could say -3 minus 5 is -8, but distance cannot be in minus, so you put a modulus. Modulus of -8 is +8. Similarly, you can write 5 minus of -3, 5 plus 3, it will become 8. So there is 8 units of distance, right? So whenever you want to find gap or distance between 2 points, how will I find out? I will subtract them, I will put modulus to it, I'm going to get the gap, right? I hope it is clear so far. Very good. Now, keeping this in mind, let us try to understand the definition of limit, right? Now, there are two ways in which I can define the limit. First ways I will tell you in a simple English, then I will give you a perfect mathematical definition. Simply, if you want to say limit of a function, you will write it like this. You will say limit x tends to a, f of x is equal to L. This is how you write, sir. Right? The meaning of this is what? The meaning of this, if you want to understand it in English, the meaning is very simple. As your x approaches a, your f of x will approach. As your x approaches a, your f of x will approach L, right? Very simple, sir. Limit x tends to a, f of x is equal to L. What is the meaning of it? As x tends to a or as x approaches to a, your f of x will approach to L, right? So as x tends to a, f of x tends to L, this is the general English way of saying if this goes to this, this is going to this. Now, how can you say mathematically, sir? How can you say the same thing in terms of mathematics? Because in English, we simply say that this approaches, but in mathematical terms, we cannot say what is the meaning of approach, right? So, let me write the definition of it, the mathematical definition of it. The mathematical definition will be like this. It will be the number L is said to be, the number L is said to be limit of f of x as x tends to a, if and only if, right? This is simple English. Number L, this is the number L, is said to be limit of the function f of x as x tends to a if and only if. This, from here the definition starts. There exists a small positive integer, epsilon, however small but not zero, however small but not zero. That means if and only if, I am telling the condition from here, there exists a small positive integer epsilon for all delta, for all numbers delta, such that modulus of x minus a less than epsilon for all modulus of f of x minus L less than delta, right? The key points are these two, sir. These two you have to understand. Whatever I'm telling in this line is like this. I'm telling that for all epsilon there will be a delta. If you take any epsilon, there exists a delta. Say your epsilon is 0.1, there will be some positive number delta. It is 0.001, there will be some value delta for it. So there will be 1-to-1 mapping between these two. Now what are these two numbers, sir? These two numbers are like this. What is the meaning of modulus of x minus a? Modulus of x minus a means the distance between the number x and the number a. This simply means that if there is a positive difference or if there is a gap between x and a, what is the gap, sir? The gap is less than epsilon. If there is a gap between x and a, definitely there is going to be a gap between f of x and a, right? That means if your x is tending to a, it has not approached a, it is actually not reached a yet. If this has not reached a yet, that means there is a gap between them. What is the gap shown as? It is some less than epsilon. If there is a gap between these two fellows, definitely there will be a gap between f of x and L, This is the mathematical way of saying the same thing, sir. Right? What is this particular saying? If this approaches to A, this approaches to N. That's the English definition. But how will you say the same thing mathematically? If there is a gap between X and A, how did you know that there is a gap? If you take the minus, that is, you subtract those two fellows and you put modulus. We know that whenever we subtract two fellows and we put modulus, you get the distance or gap between them. If there is a distance between these two fellows, definitely there will be a distance between these two fellows. Why? For every epsilon, there will be a delta. That is the mathematical definition of it, right? I hope this is clear, sir. I hope this is clear. But you'll better understand this. You'll better understand this definition when I go to examples, right? So make a note of this thing. You can ask any question if you have so far. Then I will go to the example. Once you look at certain examples, I will give you some tricky examples where you'll have to figure out what will be the limit. Then you'll understand the definition much more clearly. But from this slide, if you really want to understand the definition is very simple, sir. As x tends to A, that means if x is approaching A, f of x is approaching your L. That means if there is a positive gap between x and A, there will be definitely a positive gap between f of x and L, right? For example, if I want to show the same thing in terms of mathematics with the same mathematical example, it is like this. Say, let me take this example, sir. Let me write two examples here and you'll understand. So the first example is, say your f of x is equal to, say, x plus 1, and I'm asking limit x tends to 1 f of x. And let me write the another scenario here. Let me write my f of x is defined like this. It is also x plus 1 for all x not equal to 1, and it is equal to 3 for x is equal to 1, right? So these are two different functions. Let me call this as f of x and let me call this as f1 of x, right? Now in both of these things, I will tell you how to find the limit, what will be the limit value in these things, right? Very good, sir. So let us try to understand these things with an example. The example I've written it on the board. So let us try to solve this. So see, sir, I'm simply asking you what limit x tends to 1 f of x. So if your x is approaching to 1, where will your f of x approach to, right? Can you tell me the answer for this? Can you tell me the answer for this? Similarly, here also I want limit x tends to 1 f of x, right? It would be great if you give me the answers. If you can tell me the answer of this as well as this, and I'll show you what the correct answer is. This is a very simple question I've given. I will complicate it as we go further, but make sure you first basically understand the concept behind this. Anybody from the students, sir, who can answer what is the answer for this question, also this question? Yes, sir. Anyone who can give the answer for these two questions? Anyone with an answer? Whatever it is, it might be a wrong answer. No problem, sir. You will definitely learn from here, but make sure you have the courage to write the answer. Let it be wrong, not a problem. If it is wrong, you will get corrected. If it is right, your confidence will improve. If you don't write anything, then you will not get confidence, right? So when you involve only, you will get your confidence high. So make sure whatever answer, whatever you feel the answer is, you write down. So make sure you give the answer for this one and obviously this one also. Yes, sir. Anyone from the chat? Anyone who wants to give the answer for both of these? Yes, sir. I'm waiting for the answer. Anyone who has an answer for these two questions? Very simple questions, sir. These are very, very easy, very, very simple questions, in fact. Yes, sir. Anyone with an answer? 2 and 3. Very good. So Azhar has given this one. So let me write your answers, Azhar. Azhar is telling, so the answer for this is 2. The answer for this is 3. Very good, sir. Kritisha is also telling 2 and 3. Very good, sir. Any other answer you want to say? Any other answer? So let's try to understand. Great thing, sir. You answered it. Nice. If it is correct, then your concept will improve. If it is wrong, you'll learn something new, right? Now let us try to understand the easy one first. If I want to understand the easy one, see, this is x, this is a, this is your f of x, right? Now, because x tends to a, f of x tends to L, so your x is value here and your a is 1. So generally how do we do is, it is like this. Say your x is equal to 1 is here. Say this is your x is equal to 1. Because my x has to approach 1. So in how many ways can it approach? It can either approach from here or it can either approach from here. If it is approaching from here, we'll call it as left hand limit. If it is approaching from here, we'll call it as right hand limit. Because this is the left hand side I'm approaching from, this is the right hand side I'm approaching from. What is this value? This is actually a. This is x is equal to a point. This is x is equal to a point, right? So see, sir. Say I'm approaching from left hand side. So if I'm approaching from left hand side, so left hand limit. Say I will put my x is 0. Say I have to go closer to it because I have to approach 1. Say I'm going 0.5. Say I'm going 0.9. Say I'm going 0.999. Say I'm going 0.999999 like this. If this is what is happening, then if your x is 0, say you're here, somewhere here, you are 0 it here. If your x is 0, then what is your f of x, sir? Your f of x is 0 plus 1, your f of x. Sir, it will be 1. Sir, it will be, for this it will be 1.5. Sir, it will be 1.9. It will be 1.999. It will be 1.999999, right? So if you can see here, your x is actually approaching what? Your x is actually approaching 1. If your x is approaching 1, how does your f of x is looking like? Sir, it is looking like it will approach 2. It is looking like it will approach to 2. This is from the left hand side. If I look at it on the right hand side, this is only one part. That is left hand side if I am approaching from. If I have to approach it from right hand side, say if I want to see the same thing from right hand side means say somewhere here. I am here, sir. Let me take x is equal to 2. So if I am at 2, if your x is 2, then what will be your f of x? I have to go closer to 1. So say 1.5 because I am trying to move this side. Say 1.1. Say 1.01. Say 1.00001. Say 1.000000001. Then how does your f of x look like? Your f of x looks like, say this is 2. If this is 2, this is going to be 3. This is going to be how much? 2.5. Then this is going to be 2.1, 2.01, 2.0001, 2.00000001. Right? So how is it looking? Sir, it is looking like if this fellow is approaching to 1, then it is looking like this fellow is approaching to 2. Right? So beautifully, sir, the answer for this question 2 is perfectly right. Right? So this is how you evaluate. Right? Now this is actually a very simple question. You could directly say, sir, put this value here, 1 plus 1, 2, you will get the answer. Right? In fact, the same thing you might have done here. Right? So whoever has given the answer, like Azhar and Kritisha, whoever has given the answer, The first one is perfectly right, but you have made a mistake in the second one, sir. Right? The answer of this is not 3. The answer of this is also 2. That is where you have to understand the definition of limit, right? Because you might have understood all of this, but see, what is the point of writing all these things, and why did I take simply x plus 1 is just to make it this example. It looks like, because if you go much closer, how can you go much closer? Say I have written 0.999999. If you write 0.99999999, what will you get? 1.99999999. So it looks like if this goes to 1, this goes to 2 from the left hand side. Similarly on the right hand side also, if this goes to 1, it looks like it goes to 2. Similarly, if you look at this, where I have to approach? I have to approach to the point x equal to 1. I have to approach to what point? I have to approach to the point x equal to 1. If I have to approach to the point x equal to 1, how can I approach, sir? Sir, this is where your x is equal to 1 is. So, sir, I can approach from this side. I can approach from this side. Right? So, if you are approaching from this side and this side, how does it look like? Say you are approaching from here, and the definition of the function is like this. How is the definition of the function? The function is defined in such a way that at x equal to 1, the value of the function is 3. But at x not equal to 1, that means it could be say 0.9999999 or x equal to 1.000000001. Right? At those values of x, what you should take your f of x as? X plus 1. Right? So same thing I'll do. Excuse me. I will simply write say x is 0. What will I get, sir? X is 0 means that is not equal to 1. So I have to write x plus 1. So 0 plus 1 is 1. Say I have taken x is equal to 0.5. 0.5 is not equal to 1. So 0.5 plus 1 is 1.5. Then say x is not equal, say I am taking x equal to 0.9 because I am approaching from left hand side. So it is not equal to 1. So I will write 0.9 plus 1, 1.9. You are not actually going to the point x equal to 1. You are actually approaching the point. If you are approaching this point, how does this look like? It will look like, because always I have to take this particular definition only, that x plus 1. Exactly at x equal to 1, the value will become 3. Right? So all this definition, say x is equal to 0, x equal to 0.5, x equal to 0.9, x equal to 0.9999, x equal to 0.6 nines, say 10 nines, 100 nines you put, it will look like it is going to 2. Similarly, if you write from the right hand side also, it will look like it is going to 2 only. Right? So as the definition, it is looking like if it is approaching to 1, it looks like it might approach to 2. Because the function is defined like this, that is why the answer is 2. Right? Now, sir, but what is f of 1? Sir, but f of 1 is 3. Right? And what is your limit? X tends to 1, f of x. Sir, this is 2. Right? Now, whenever the next topic which I told you is continuity, whenever limit of a function is not same as the value of the function, whenever this is the limit of the function at a point, this is the value of the function at that point. When these two are not equal, it is not continuous. It is not continuous. But this is, for this example, what is f of 1? Sir, f of 1 is 2. Sir, what is limit x tends to 1 f of x? Sir, this is also 2. So, limit of the function and value of the function, if they both are same, then it is continuous. If the limit of the function and the value of the function are not same, then they are not continuous. Right? Because according to the function definition, as x is approaching to 1, it looks like your f of x might approach to 2. Right? Did you understand this point? Azhar and Kritisha? Did you understand this point, sir? Did you understand the point which I am trying to make? You have not, for continuity you will check this. Right? But I am not talking about continuity yet. I am simply talking about limit. Limit means as x approaches to something, how does the f of x will approach to? Is this clear, sir? Can you tell me? Did you understand this point? Did you understand this point? Very good, sir. Awesome. Just to make this concept much stronger, let me give you one more small question. Just to make it stronger, I will give you two more questions I will give you. Say your f of x is like this. Say your f of x is, say x square, say it is 5 for all x not equal to 2, for x equal to 2. I am asking limit x tends to 2 f of x, right? And the next question I'm giving is like this. Say your f of x is actually x plus 1, or let me write it like this just to make it easy, or let me write this only, sir. X plus 1 x minus 1. This is for all x greater than or equal to 0. This is for x less than 0, and I'm asking limit x tends to 0 f of x, right? Now, two questions again. This will just help you understand the concept in much better way. So take your time, there is no hurry. Take your time and try to answer this question. I will elaborately talk about this. Tell me the answer for this. First tell me the answer for this, then we'll talk about this. Azhar, did you understand this last two questions? I hope you understand this question, sir. You could actually write it in the chat. Tell me, sir, did you understand that? The last question. If not, I can repeat it. If not, I can definitely repeat it, sir. And if you have understood, then obviously you move forward. You try to do this question. You're trying to understand the concept of limit. Take your minutes time. You do the analysis like this and come up with the answer for this particular question. There's no hurry, sir. You're trying to learn. So you put enough time in class or when you're practicing, then you'll become fast. And in exam, you won't do the time. Like in exam, you don't take this much time, right? In fact, these are actually quite easy ones. So this is just for building your concept. So can you tell me the answer for this question, sir? F of x equal to x square for x not equal to 2 and f of x equal to 5 for x equal to 2. Can you tell me the answer for limit x tends to 2 f of x? Take your time and give me the answer, sir. It is in fact same as last question only. I'll just understand how much you got it. Yes, Azhar is giving the answer as 4. Yes, Azhar, can you try the next one? Meanwhile, can you try the next one? Let the others also answer. Yes, Kritisha, if you could answer this question, it would be great. Whatever answer is, you please post your answer, sir. If it's correct, you will get confidence. If it is wrong, you will learn. But make sure you participate. All right, so let me do this, sir. Let me do this question. This is same as last thing, sir. This particular question is same as last question only, but I would like to take a different approach. Instead of taking this particular approach, which I have done it here, I would like to take another approach, right? Which would actually make it easier and faster you to understand. So see, sir, what is that approach I'm taking? You try to plot this f of x. What do you do, sir? You try to plot f of x. Sir, how can I plot this f of x? Sir, f of x will be looking like this. Say this is your x and say this is your y is equal to f of x. Now, according to the function definition, for x equal to 2, it is 5. For x not equal to 2, it is x square. So let me just put a condition. At x equal to 2 specifically, what is the value, sir? At this point particularly, it is 5. Except this point, it will look like a curve like this. It will look like what? This will look like this. In fact, if you are an electrical electronic student, there will be a subject called as signal and system. In signal and system, you will be learning how to plot, right? In fact, in calculus also, there is a small topic called as curve tracing. There also you learn how to plot any curve, because whenever you plot it, it becomes much simpler, sir, to do it. Now see, basically how this graph looks is like this. If this was simply f of x equal to x square, it would have looked like this. It will be a simple curve like this, right? But exactly at 2, I have to take a gap and I have to put the value of how much here, sir? I have to put a value of 5 here, right? Now, if you understand, if you go from this side, if you try to approach from this side, like this side, how will it look like, sir? It looks like it might go to 4. It looks like it might go to 4. We are actually not going to this point yet, but it looks like it might go to 4 because we exactly have not reached here. We are just predicting that if we are continuing to go much closer to 2, according to this curve, you might go much closer to 4 from this side. Or also, if you are coming from this side, it looks like you are also approaching to 4, isn't it? Because this is what the graph says. If you are going like this, it looks like you are approaching to 4, because what is the value of x at exactly this point? Exactly at this point, it is 4, right? So it is looking like you are trying to reach this point. If you are trying to reach this point in x, you are trying to reach this point in particular f of x. Similarly here, right? So that is why I will call what? That is why I will say the limit of this is actually equal to 4, right? Now, is this function continuous at x is equal to 2? Now I am asking, sir. I have not taught you continuity yet, but from the last concept I can understand. Is this function continuous at x is equal to 2? Please answer this, sir. Is this continuous at x is equal to 2? Is this continuous at x is equal to 2? From the graph only you can say. Is this particular function f of x continuous at x is equal to 2? Can you tell me, sir, is this function f of x continuous at x is equal to 2? See, sir, it is. I would like to answer you. Make sure you give me the answer, sir. Take your time, not a problem. Is this function f of x continuous at x is equal to 2? Because what is f of 2? 5. What is limit x tends to 2 f of x? At limit x tends to 2 f of x is 4. And f of x at x is equal to 2 is 5, so it is not continuous. So from the graph also it clearly looks, you have to draw it like this. There is a transition at this particular point. I have to put a dot here, then I have to put like this. So this is what? This is discontinuous. Is this clear? I hope you have understood the concept behind the limit. You are actually not going to check at that point, but you are going to understand it like this, right? Very good, sir. But I will actually contradict my statement, or I will, whenever we are calculating limit, because you might say, sir, generally whenever you are trying to calculate the limit, we simply take this value and put it in this and we calculate, right? Yeah, we will do that, but you can only do that when your function is polynomial, right? Whenever there is no breakage like this, whenever your function definition is not breaking, then you can do it like this, right? Very good. So let me do the next one. Can you tell me the answer for next one? This one, sir. Can you tell me the answer for this one? This becomes an interesting question. take your time, try to tell me the answer for this, keeping the concepts which you have just learned in the mind. Can you tell me what's the value or what's the limit x tends to 0 f of x? Yes, sir. Take your time and try to give me the answer. F of x equal to x plus 1 for x greater than or equal to 0, x minus 1 for x less than 0. Yes, sir. Try to shoot your answers. One and minus 1 discontinuous. Very good. So this comes to a beautiful point which I have to make. So Azhar, with whatever knowledge he has or whatever concept we have understood, he told 1 and minus 1, right? And he told it's discontinuous. Now let us try to do this, sir. If I try to do it, let me check left hand limit. If I check left hand limit means I have to go where? This is the number line I have. I am at x equal to 0. I have to go from this side, and this will be right hand side. So if I'm going from this side, what does it look like, sir? Say your x and say your f of x. I have to go from this side, so it could be minus 1. No, I have to go much closer. Minus 0.5. No, minus 0.9, minus 0.99, sorry, minus 0.1, minus 0.01, minus 0.0001, like this it will come. Because this is where you have minus 1, this is where you have minus 0.5, this is where you have minus 0.1. So you are trying to approach to 0 from the left hand side, right? If you do that, see sir, what are you going to get here? See sir, your x is less than 0. So which value I should take? X minus 1 I should take. So x minus 1 is minus 1, minus 1, minus 2. Minus 1, minus 0.5, so minus 1.5. This is minus 1.1, minus 1.01, minus 1.0001, right? So if this fellow is trying to approach to 0, it looks like this fellow is approaching to minus 1, right? Isn't it? Because if your x has to approach to what? X has to approach to 0, and from left hand side I am approaching, so that means this side. So it could be minus 1, minus 0.5, minus 0.1, minus 0.01, minus 0.001, not 1, like that, right? So for all these x's, whatever my f of x I am getting, sir, it looks like this is also coming to minus 1. So what is the left hand limit? If I simply ask you, what is the limit x tends to 0 minus? 0 minus means less than x, or left hand side of x is equal to 0. F of x. What will be this value? Sir, this value should be minus 1, right? Very good. Similarly, if I go from right hand side, if I go from right hand limit, if I see my f of x and x can be what? I have to come from here. So my x can be 1, it can be 0.5, it can be 0.1, it can be 0.01, it can be 0.0001, it can be 0.000001, like this. So if it is like this, then for x is equal to 1, sir, x is equal to 1 is greater than or equal to 0. So you have to take 0 plus or 1 plus 1, 2. You will get 2 here. And this is also, I have to use this definition. So 1.5. So 1.1. So 1.01. 1.0001. 1.01. 0, 0, 0, 0, 0, 1. Sir, it looks like if this fellow is going to 0, it looks like this fellow is going to, right? Now, if you go from right hand side, that is x tends to 0 plus f of x, what I am getting it as 1, right? Now, which should be the answer, sir? Which should be the answer? If I go from one side, I am getting it as minus 1. If I go from other side, I am getting it as plus 1. So, which of this should be answer, sir? Which should I choose the answer as? So, tell me, sir, I got two answers. So, which one of this should be right? Give your opinion, sir. Which one of this should be right? Because if I am going from left hand side, I am getting one answer. If I am coming from right hand side, I am getting another answer. Which one of this I should take the answer as? 1, minus 1, both, none. Let me give the options. Say option A is 1, option B is minus 1, option C is both 1 and minus 1, option C is none of this. That means limit does not exist. Yes, sir. Try to give your answer. What should I take the answer as? This or this? Or both or none? You have four options in front of you, sir. Should I take 1 or should I take minus 1 or should I take both are correct or should I take none of it is correct? Just give your opinion, sir. Yeah, so Azhar is saying both. Very good. Now the point is like this. Whenever you simply say x approaches to a, right? What we said in the limit, sir, we said, sir, limit x tends to a f of x. That means as x approaches to a, f of x approaches to what? Now we are in a system where y is equal to f of x is there. That means only two lines will be there like this. That means only one independent axis will be there, one dependent axis will be there. Now, as per the definition, or if you want to understand, it has to approach a. In how many ways it can approach? So it can approach from two ways. In both ways it should come same, right? Because it's simply telling x approaches to a. Let it approach from left hand side, let it approach from right hand side. Either ways if it is approaching, it should give the same answer. Then only whatever the same answer is, I will say that is the limit of the function. If either ways it is coming not same, that means from this side it is giving one answer, from this side it is giving one answer. So I cannot say, because whenever you simply write limit x tends to 1, because I will say, sir, limit x tends to 0 f of x. Now someone will argue that, sir, I am coming from this side, I am properly approaching to x is equal to 0, I am getting minus 1. Some other will argue, sir, I am getting from this side, I am also properly approaching, I am getting this is answer. So there is a conflict happening. So whenever there is a conflict happening, you cannot say both will be the answers. You will say none of you are correct, right? So whenever these two are not equal, whenever left hand limit and right hand limit are not equal, you simply say limit does not exist. You will simply say limit does not exist. Because I don't want a conflict, sir, right? Someone will say, sir, I am approaching from this side, the answer should be minus 1. Someone will say, I am approaching from right side, the answer should be plus 1. But whenever there is a conflict coming like this, he will say, okay, whenever there is a conflict, I will simply say that for this function, at that point, limit value does not exist. Why? Because it is giving multiple answers. Whenever it gives multiple answers, I will say limit does not exist. Right? I hope you understood this point. Now let me just add on to this. Just a small thing I would like to add. Say if you have something like this. Say if you have limit, say x tends to a, y tends to b, f of x comma y. Say n. Right? Now this is, you will learn in partial differentiation or limit of two variable function. You will learn it there, but I'm just giving you an idea How does this look like, sir? If you see graphically, this will look like this. This will be Z, this will be X, this will be say X, this will be Y, this will be Z. Right? Similarly, what I have here, sir, I have limit x tends to a, f of x is equal to L. Right? Here what I have, here I have something like this. Because y is equal to f of x, so this is x, this is y is equal to f of x. This is z is equal to what? This is z, sir. This z is equal to what? F of x comma y. Right? Now in this, I have to say approach x is equal to a. So how will I approach? There are only two ways I can approach. Right hand side and left hand side. So both sides, if it is approaching the same value, then only the limit will exist, or else it will not exist. Similarly, say this is a point a comma b, isn't it? Say suppose this is a units from here x is equal to a, say this is b units from here. Right? Now, how can I approach, in how many ways can I approach to this particular point? In how many ways can I approach to this particular point? Here you told, sir, only two ways are there, because you have left hand side, you have right hand side. Here how many ways there are there, sir? This is just for you to think. If I want to approach to this point a comma b, say I am sitting at origin. Just imagine your point is at origin. In how many ways can I approach, sir? From here to here, in how many ways I can approach? In how many ways I can approach, sir? 1, 2, 3 or 4 or like that. From here to here, how many ways I can approach? I hope you are understanding what I am trying to say here as well as here. This you will study, obviously separately we'll study about this, but just as a idea of thought I am giving you, sir. I am giving this as a question, so make sure you understand this, then you will understand the significance of this. Can you tell me, if I am at 0, 0, in how many ways can I approach to this a comma b? If I am sitting at 0, 0, like for example, if I am sitting at 0, I can go only this way. There is only one way. Say if I am at, say, some a plus 1, how can I approach to a? Like this I can approach. Similarly, if you are at 0, 0, how can I approach to this point a comma b? Sir, why you want to approach? Because limit x tends to a, y tends to b, f of x comma y is equal to L, I am saying. Yes, sir. Can you tell me in how many ways can I go from here to here? 1 way, 2 way, 3 way. Can you tell me like that? Don't know is also a very good answer. If you could say, sir, don't know, then it's all right. Because if you say don't know, I will obviously help you. Yes, sir. So question is, if I am here, from here to here, in how many ways I can approach? Yes, sir. 4 ways. Azhar is telling 4 ways. Any other answer, sir? No, you might say, sir, 1 way, 2 way, 3 way, 4 ways. How 4th way? 4 ways. Very good, sir. So that is where the beauty lies. It is not 4 ways, it is not 1 way, it is not 2 way, it is infinite ways. Sir, how infinite ways? See, I can draw a line like this. I can draw a curve like this. I can draw another curve like this. I can draw a triangle like this. I can draw a sinusoidal like this. I can draw a big curve like this, isn't it? Because ultimately I have to go from here to here. Path I did not mention. Whenever path is not mentioned, from this point to this point I can go in many ways. In fact, infinite ways. How many ways, sir? In infinite ways I will go. Sir, if it is infinite, then how will we find the answer? That is why we have multivariable. Whenever we go to multivariable, calculus is most difficult, sir. Calculus is good, but you just switch to multivariable. Beautifully, you'll understand that is going to be very, very difficult. Obviously, we have certain methods to find it, But simply you can say, sir, you can go like this. Let me just use the other pen. You could say, sir, I can go like this, go like this. On this line I can go. On this curve also I can go. On this curve also I can go. On this sine curve I can go. On this curve I can go like this. So there are infinite ways. So whenever I'm finding this limit, all the ways I have to check. In all the ways where x tends to a, y tends to b, all the ways in which x tends to a, y tends to b, your f of x tends to l. So there the definition will be like this. There the definition will be like this, sir. Around this he will draw a circle. What he will do, around whichever point you want to go, say I want to approach to this point, so he will say around this circle, he will draw a circle like this, and he will say the radius of the circle is r. So in however ways, because I told you this line, all of this curve will actually have to enter this circle only. So I will say the region here. What can I say? It could be circle, it could be square, it could be any region like this. So we will say in any ways in that region, if this is approaching in all these ways, and in all the ways if the value of the limit x tends to a, y tends to be f of x comma y is coming L, then only the limit exists. When will the limit exist? Now this is, we will talk about this. This limit will exist. This limit will exist if limit x tends to a minus f of x is same as limit x tends to a plus f of x. So if these both are same as L, then only the limit will exist, right? So from left hand side or from right hand side, if the both are same, then only the limit will exist, or else the limit will not exist, right? Similarly, this limit, obviously I will talk more about this when I go to partial differentiation, but try to get the idea, sir. This limit will exist. This limit will exist if in all ways x tends to a, y tends to b, your f of x should be L. Always I means in however manner. Who said the starting point is here? Say your starting point could be here also, it could be here also. So in wherever you start from, but you are on a plane. Now this is a line, the line has only two dimensions, isn't it? Say this is a line, so I can only move on a line, that's why I had only two dimensions. But you just increase the line to a sheet. Whenever you are on a sheet, how can I roam, sir? I can roam however I want on a sheet, right? Isn't it? Say there is a string like this, you leave an ant on the string, it can move forward, it can move backward, only two ways. But you put a paper and you put an ant on it, how can the ant go? The ant can go in whichever direction it wants. It might go straight, it might go in circle, it might go a sinusoidal, in however like it way. In all the ways, the function should approach f of x equal to L, then only the limit will exist. But this is more complicated if you understand. But if you look at this and if you look at this, this becomes much simpler. You are on a line, there are only two ways. In both ways, if it comes to be same, then only it will exist, right? I hope this point is clear to you, sir. I hope this particular point is clear to you. In fact, you remember that on a wire there is an ant, on a sheet there is an ant. How will the ant move, right? I hope this is clear, right? So let me just tell you what all we have understood so far, then I will go to the next point. So see, sir, what all we have understood is like this. Let me just revise you what we have done. So we have started with basically, I told you we are starting engineering mathematics. In engineering mathematics, I told we have 6 to 7 chapters based on your branch. Then I told you will get 12 to 15 marks, of which 10 marks are pretty easy to score, sir. In fact, I myself, I did not introduce myself. Actually, my name is Sai Kiran Singarao sir. Actually, my AIR rank is 437. I have done my masters in ISC Bangalore, right, in 2011 sir. So it was like very 10 years old. I secured this rank, and I tell you sir, in maths I got 14 marks. I actually was very good at maths from that time. So 14 marks in maths and in aptitude also sir. Aptitude I got 10 marks. So of this, actually I got a marks of 62. So at that time 62 mark was a pretty good mark. So here 24 more marks out of 62 marks are only from your maths and aptitude, right? The other technical subjects, I was from electrical branch. So electrical is actually considered a very long branch. The syllabus of electrical engineering is much higher. In fact, when I was preparing for GATE in 2011, I left 1 or 2 technical subjects, right? Because the syllabus was very high. I couldn't complete them, but I did not leave maths and aptitude because I know these are free marks. Because if you are good at math and aptitude, then only you will not make any calculation mistakes in your technical subjects also. So I will tell every student to put maximum time on maths and aptitude. Out of maths and aptitude, if you try to get 20 marks, I'm not telling 25, 30, try to get 20 marks. And 40 marks you can easily get in your technical subjects. If the paper is easy, then obviously this 20 can go to 25, that 40 can go to 50. You will land up anywhere between 60 to 70. 60 to 70 marks in GATE examination is pretty good sir. You will definitely achieve a rank below 1000, right? If the paper is very easy, maybe you might have to go beyond 80. And obviously if the paper is easy, actually it is very problematic sir, because a small silly mistake can cause you a very large gap in the rank. Just wish your paper is hard. If your paper is hard, the maximum mark won't go beyond 80. It would be around 70, 75 and 80 is maximum, right? Because the paper is tough. If your paper is tough, but he will not design the paper in such a way that nobody would be able to score 50 or 60. He will averagely say that, because 100 for 100 marks, average mark is 60. So average questions will be 60 only. So like average marks will be 60 only. So it will be easy to get 60 marks, right? I am not that a great student sir. When I was studying my bachelor's, my BTech percentage is 65% only, right? So I was actually a very average student. But I have done it from a very good college, Usman University, Hyderabad. I have done it sir. So it's a good college, but I was not a good student. But I have studied it tactically. I got 24 marks from maths and aptitude only. But my technical subjects, I tried to get 40 marks from there. Then I ended up around 60, 62, right? So which gave me a pretty good rank. So make sure you don't neglect your mathematics and aptitude. If you don't neglect these things, it would be much great for you, sir, right? Then again, your technical subjects also, there are some easy subjects, there are some hard subjects. In easy subjects, I would say basic subjects will be there. Try to cover them first. Any day, any student, if they have studied their BTech properly, or if they have done their coaching properly, 40 marks is the minimum marks you could get, right? 35 to 40 marks if you are getting only by listening to classes and just practicing the class notes, you should be able to get that. If you want to go beyond 50s, 60s, your effort is needed, right? So for that purpose, engineering mathematics is going to give you 10 easy marks. So make sure you study this, and whatever you're studying in this will definitely help you in your technical subjects also, right? So today, as an introduction or as a demo, I am taking up calculus, and I told you the importance of calculus. Literally the meaning of calculus is a small stone or a pebble which is used, like there was an abacus instrument which was used for counting. Similarly, we have differential calculus, integral calculus, vector calculus, which are actually evaluation only we are doing. So indirectly we are doing counting only. So I have told you differential calculus, integral calculus, vector calculus, right? Then I told you what is the differentiation meaning. Remember, always remember this sir, differentiation means slope, integration means area, right? Differentiation means slope, integration means area. Vector means based on the length, area and volume, differential changes you are seeing, right? So then we started differential calculus. In differential calculus, I told you applications part is most important. When I said applications, maxima minima is where you could get a question from, right? Or Taylor series, Maclaurin series, or he could go get to basics and he can ask from there. This is for what? Single variable function y is equal to f of x. If you have multivariable function z is equal to f of x comma y, then you will get partial derivative, then you get homogeneous equation, then you have Euler's theorem, then you have their applications, right? So this is the syllabus of your differential calculus. In all of this, to understand evaluation of derivatives, to understand maximum, whenever you want to find the differentiation only, you have to first understand the crux, that is limit and continuity. So we have started the lecture limit. So from here you could pay attention. Only 3 to 4 points I will tell, sir. Limit means what? As x tends to a, f of x tends to l. That means if your x is going towards a, it looks like f of x is going towards l, right? How do you know that it is going towards this, it is going towards this? There is a small trick I told you. Whenever you want to see there is a distance between these two fellows, 2 points, how can you say? You take the subtraction, you put modulus, right? Then you'll get the difference. So similarly, I told modulus of x minus l less than epsilon for all f of x less than f of x minus l less than delta. So for every epsilon, if there exists a delta, that means if there is a gap between these two fellows, definitely there will be a gap between these two fellows. That is the meaning of limit. That is why in the numericals also, actually I did not go anywhere. I just told if this approaches to this, it looks like this approaches to this, right? It approaches to this, it looks like it approaches to this. So first point is approaching only we are seeing, right? We are not looking at the limit at that particular point. Next, second point is let these two not be equal. That means limit of a function, value of a function. Let those two things not be equal. That will come in continuously. If they are equal, then they will become continuous. If they are not equal, they will not be continuous, right? You should always check the way in which it is approaching. Next, the second most important point which I told you is this point. If you are approaching, if you are on a line, you can approach to a point in only two ways, left hand side and right hand side. If from both these sides, if the limit is same, then only the limit will exist. That means we have seen the condition for existence of limit. When will the limit exist? If the left hand limit and the right hand limit, if they are same, then only the limit will exist, right? So far I hope this is clear, sir. If you have any question so far, you could post, or else I will move forward. Any question you have, you can ask. Any question so far, or is it clear? Just very simple 2-3 points. Is this clear? Should I move forward? Is everything clear so far? Tell me, sir, is everything clear so far? Should I move forward? Yes, sir. Is everything clear so far? Very good, sir. Very good. So let me, I have a few more time. I have 25 minutes more. So let me give you some more points which are actually beneficial. So see, now we have seen the definition, the first point. We have seen the second point, the existence of the limit. Now let me go to the third point. You could actually remember it as points also. It will help you whenever you revise. So limit definition is the first point which I taught you. The second point I taught you is the existence. Existence is the second point I taught you. Let me go to the third point. Third and most important point. What all values can your limit take? That means, can the limit of a function be equal to 0? Can it be equal to some finite value? Can it be equal to some infinite value? Right? So let me post a question. And limit x tends to a f of x equal to Can it be equal to 0, or can it be equal to some finite number, or can it be equal to infinite, or all are possible? All are possible. Just a small question I'm posting you, sir. We have understood the definition, we have understood its existence. I did not tell you how to evaluate it yet. I have few more points to make. How to evaluate, I'll tell you, but let me post you a question. Can the limit of a function be 0? Can it be finite? Can it be infinite? Or it can be any of this? Tell me, sir. Can it be 0? Can it be finite? Can it be infinite? Can it be any of this? Can the limit of a function be 0, or can it not be 0? Can it be some finite value? Can it not be some finite value? Can it be an infinite value? Can it not be infinite value? Or like any of this is possible? I'm just waiting for you to reply. Tell me, sir, which of this should come? Can limit of the value take any of these values? Can limit of a function take any of these values? Any of this possible? Very good, sir. Any of this is possible. It can be 0, it can be finite, it can be infinite. Any of this is also possible. For example, let me just give you a small question and let me see how you understood or how much you have understood so far. Just a small question, very small question. If you could answer this, then I would feel very happy that you have understood the concept which I am talking about. What is the limit of this? What is limit x tends to 0, 1 by x? What is limit x tends to 0, 1 by x? Yes, Azhar will give me the answer now. Infinite. Very good, sir. Any other student? Any other student has any other answer? Kritisha, you have any other answer, sir? Other, just think one more time. Take 1 more minute or 2 more minutes. Think and just try to review your answer. Take it as a second chance. Think and try to give me the answer again. Azhar, you're from which branch? Your branch of engineering? From which branch do you belong? Yes, sir. Any other student has any other answer for this question? Oh, triple E. Awesome. If you're from triple E, then maybe I'll only teach you power systems. I'll only teach you control systems, sir. Right? Awesome. Right. So maybe Kritisha could answer infinity. Very good, sir. See, let me just tell you, the answer is does not exist. The answer is limit does not exist. Sir, what is this, sir? Just now you have told it could be infinite, but you're telling the limit does not exist for this. See, there's a catch. The catch is very simple, sir. Whenever you're giving the answer, at least at this stage, you have to understand that you have to check whether it is from left hand side or it is from right hand side, it's giving same value or not, right? I will give you some points as we move forward that your function is whenever does not have any discontinuities, then you could simply substitute the value and you can tell the answer. But for this question, the limit does not exist. Why it is like this? Because if I find limit x tends to 0 minus 1 by x, tell me the answer for this, and limit x tends to 0 plus 1 by x. Tell me the answer for this and this. Tell me the first one, tell me the second one. Then you will only understand whatever I told you is right or wrong. Try to give me the answer, sir. Left hand side and right hand side, you tell me. Left hand side and right hand side, you tell me. Left hand side and right hand side, you tell me, sir. Left hand side, x tends to 0 minus 1 by x, x tends to 0 plus 1 by x. Yes, sir. This one and this one, please tell me what would be limit x tends to 0 minus 1 by x. Kritisha, from which branch are you? Tell me your branch, because if you're from electronics, then I will talk more about the curve tracing also, because you will need it in your signal and system. Tell me for this one and this one, what is the answer you're getting, sir? Tell me for first one you're getting what, second one you're getting what? CSE, all right. Tell me what are you getting for this as well as this. Then you will only say that this answer is perfectly right, sir. 1 minus 1, no. Minus 1 plus 1. No, sir, you made some mistake. All right. So see, I will tell with the graphical way also. But say if you don't know how to plot a graph, it is like this. Sir, if I want to find left hand limit, I have to approach my x to 0 from left hand side, isn't it? Because I am here, I have to approach from here. So my x could be what, sir? It could be minus 1, it could be minus 0.5, it could be minus 0.1, it could be minus 0.01, minus 0.000001, minus 0.000001, right? So if it is any of this, sir, if it is minus 1, if it is minus 1, if it is minus 1, what is 1 by minus 1? Because this is my f of x. Sir, 1 by minus 1 is minus 1 only, isn't it? Sir, what is 1 by minus 0.5? Sir, this is minus 2. Sir, this is minus 10. Sir, this is minus 100. Sir, this is minus 1, 2, 3, 4, 5. Sir, this is minus 1, 2, 3, 4, 5, 6, 7, like this. So it looks like if this fellow is going to 0, it looks like, sir, this fellow is going to negative infinity, isn't it? What is the meaning of infinity? Infinity is undefined. We don't know what it is. Or we can also say infinity is a very large value, right? So it looks like it is going to be negative infinity. It looks like it is going to be negative infinity. Similarly, if I have to find the right hand limit, see, right hand side I have to approach, from this side I have to approach. So you could be 1, it could be 0.5, 0.1, 0.001, like that. It could be 1, it could be 0.5, it could be 0.1, it could be 0.001, it could be 0.0001, 0.00001. If at all it is like this, then how is my f of x going to be? Sir, my f of x is going to be 1 by 1 is 1, 1 by 0.5 is 2, 1 by 0.1 is 10, 1 by this is 10 cube, 1 by this is 10 power 4, 1 by this is 10 power 5. So it looks like if this fellow is approaching to 0, it looks like this fellow is approaching to positive infinity. What infinity? Positive infinity. So this is coming to be plus infinity, this is coming to be minus infinity. Left hand limit and right hand limit are not equal. That is why limit does not exist, right? Make sure you keep this in your mind. The existence point is very important, sir. Some basic question. This is a very basic question. you could simply, the first option only he'll give infinity. Then you will directly tick the first option, you will come, it will be wrong, right? He will give the last option as does not exist. So students will generally make a mistake. So whatever point you are studying, you make sure you understand the crux of the point and you understand how the examiner will use that. Because if I'm going to set the question paper, because just now I taught you that and then I just gave you a question. So you made a mistake. So make sure you don't do mistake like this. Every point you're studying, just store the point and try to analyze the point whenever you're doing a question on that, right? So I hope this point is clear to you. I hope this point is clear to you. Is this question clear, sir? Can you just tell me, did you understand this question? Azhar and Kritisha, did you understand this point which I'm trying to make? Yes, sir. Beautiful. So whenever we have left hand limit equal to right hand limit, for all these things, left hand limit should be equal to right hand limit, then only if it comes any of this, then that should be right answer. Just if I modify this question, if I just take a step ahead and if I just modify this question like this, if I just modify the same question, then you would give me the answer. If I modify the question like this, say limit x tends to 0, 1 by modulus of x, what will be this? Now you can give me the answers. Now I've just changed the question. I've just added a modulus sign. Now you would be easily able to give the answer for this. What would be the answer for this? What would be the answer for this, sir? Just I did modulus of x. Here it was no modulus, here it was modulus. What will happen to the answer? Yes, sir. Very simple. You could answer it now. Just an extension of this. Just an extension. Just an extension. Yes, sir. You should be able to answer it. Very simple. Very simple, sir. If you have understood this part, then easily you will understand this part. I hope you are understanding how I am writing these things, right? See, when x is minus 1, 1 by minus 1 is minus 1. When x is minus 0.5, 1 by minus 0.5 is minus 2 because 1 by minus 1 by 2 is 2. Minus 0.1, 1 by minus 0.1 is minus 10. I hope this simplification you are able to understand fast because it's a very simple thing, so I've written it a bit fast. So if you have understood this point and this point, then you should be able to tell the answer for this. What should be the answer for this? Yes, sir. Just take a minute and give me the answer. Finite, how is it finite? It's infinite only. It is infinite only, sir. The answer is infinite. See, let me just take the last few minutes to tell me that thing, right? Very simple. Let me just do it the basic way which I was doing. Then I will just draw the graph. Once I draw the graph, then you will easily understand what is happening, right? So it is like this, sir. You have to approach to 0, isn't it? You have to approach to 0. Sir, I can approach from this side. I can approach from this side. Sir, if I approach from this side, I have minus 1. I have minus 1 by 2. I have minus 1 by 10. I have minus 1 by 100, like that. If I am approaching from this side, I have plus 1, I have plus 1 by 2, I have plus 1 by 10, I have plus 1 by 100, isn't it? I can go like this or I can go like this, right? Now see, if I am assuming I am going from left hand side, see what all values my x can take on left hand side. See sir, I have to approach to 0. From left hand side I have to approach. Sir, your x could be minus 1. Sir, no, it could be minus 1 by 2 also. Sir, it could be minus 1 by 10 also. Or sir, it could be minus 1 by 100 also. These things only I wrote like this. Minus 0.5, minus 0.1, minus 0.01, like this I wrote. Or say minus 1 by 1, 0, 0, 0, 0, 0. That means minus 0 0.1, 2, 3, 4, like 1, 2, 3, 4, 5, like this, roughly. Right? Because I am approaching to this on left hand side. Now see, if this is your x, what is your f of x, sir? Sir, f of x is 1 by modulus of x, isn't it? Maybe you just got confused while implementing this. If I keep, in place of x, if I keep minus 1, what will I get? 1 by modulus of minus 1. Sir, what is modulus of minus 1? Sir, plus 1. Sir, what is 1 by 1? 1. Similarly, sir, what is 1 by modulus of minus 0.5? Sir, it is 1 by 0.5. Sir, 1 by 0.5 is 2. Sir, this is 1 by modulus of minus 0.1. Sir, modulus is there, so minus will become plus. It will become this, it will become 10. For this, sir, it is 1 by modulus of minus 0.000001. So that will be 0.000001. Sir, that is 10 power 1, 2, 3, 4, 5, 6. Isn't it? 6. So it looks like if this fellow is approaching to 0, it looks like this fellow is approaching to infinity. Did you understand this? Yeah, infinity, right? Because modulus I have kept. Now the other case obviously will remain same. Because if I am approaching from this side, these negative values have become positive values and looks like it is going to plus infinity. And if I look at the right hand side, the right hand side will remain same. Because 1, 0.5, 0.01, all of this, there will be 1 by 1 positive only, 1 by 0.5, 2, 1 by 0.01. So obviously from left hand side, because last time what happened, sir? The left hand limit was minus infinity, right hand limit was plus infinity. They both were not equal, so limit does not exist. Now the left hand limit is plus infinity. We know the right hand limit will also be plus infinity. So that is why the answer will become infinity, right? So make sure you understand this basic point. Or just a simple way, these are pretty basic questions like this. I could have done like this. If you have known this particular thing, if you have known the graphs, of the function, it would have become much simpler. Sir, this is how the graph look like. This is the graph of 1 by x, right? Sir, this is how the graph look like for 1 by modulus of x, right? Once I drew the graph, you can clearly see. See sir, if I am going from left hand side, like if I am approaching from left hand side, your function is going to negative infinity. Whereas you are coming from this side, it is going to positive infinity if your function is 1 by x. That is why limit does not exist. But if I put a modulus, if you know how the graph of 1 by modulus of x will look like this. If you go from left hand side or from right hand side, it was looking like it is going to infinity only. That's why the value of the limit is infinity. Now, sir, how will I know how to draw these graphs? Either you can remember some standard graphs, or even as you go forward, I will teach you how to do curve tracing, because curve tracing is important here and it is important in integral calculus also. So you should be able to know how to trace a curve. Tracing a curve means drawing a curve. Because if you have the knowledge of how to draw a curve, it becomes simple, sir. Mathematically, it will become simple. Because if you visualize how it looks like, then this limit approaching thing will become very simple to you, right? I hope the points which I am trying to make you have understood. Is this clear so far? Is this clear so far? Just tell me, sir, is this clear so far? Did you understand so far? Is this clear so far? Azhar, did you understand this last question? Did you understand this last question? Clear. Very good, sir. Did you understand this graphs concept which I just told you? How do you draw this graphs, the curve tracing? All right. So this is just one part of it, sir. There is more to this. There is more to this. This is just I've given you the like overview or the understanding of limits only, sir. This is just the understanding of limits. I have more points to cover in limits, but the time is not permissible now. So let me stop this class here, and maybe when we meet next time, I will build upon this, right? But you make sure you understand the concept, because once your basics are clear, then only the applications will be clear, because he can ask the question either from basics or from application. Especially if you go to interview also, he might first ask application. If you do any mistake in application, he will definitely catch you on basics, right? So make sure you understand these things. I will stop it here, sir. Maybe next time when we meet, we'll try to continue this, or we'll talk more about this. So I hope you understood something, you learned something, and I will stop this class here. Let us meet in the next one. Thank you so much, sir.